Okay, quick video. We've got a pressure switch, an element from a commercial coffee machine, a temperature probe, and a solid state relay. The purpose of this video is to point out you do not need PID control, or nor is it an advantage to have a temperature probe PID controlled coffee machine. This is for home machines as well as commercial machines, instead of a traditional pressure switch. A traditional pressure switch is very reliable. I could go on and on about that, and I did, but I cut that in the previous video. They're very reliable component. They switch on and off when they reach pressure, and then they switch on again when it drops. It's simple, it's reliable. 10 years, 15 years is possible with one of those without replacing it. You don't leave them that long if you're a good service technician, but nevertheless, they're very reliable. So now looking at a temperature probe, the problem with these is that the temperature probe itself can get scaled up. It's in the coffee, in the steam boiler, typically in a single heat exchanger machine, a single boiler heat exchange machine. And it switches via the control box, PCB, what do you want to call it. It switches this, which then switches the element. Problems with this. The problems are, when this fails, quite often they fail locked on. It means the boiler will go over pressure, which is an unsafe situation. There's no need to do that. It's like designing a nuclear power plant without moderator rods or something, so that if something goes wrong, you can't even do that, but if something was to go wrong, it will go over pressure, which means there's more need for other safety components, such as to stop the machine from going into a dangerous state. There's no need to have this, though, on the steam boiler. The problem is when you buy a home machine like a Profitec or VBM Junior or something like that, typically this is what is being controlled by the temperature probe. And the other thing with this is that you think I'll get more precise control over the coffee water temperature, therefore I'll be able to adjust the coffee to suit my needs. No, you don't. You're getting control over the steam boiler, which is irrelevant because you only need rough control, and this is not rough control anyway. It's possibly more accurate. In old school engineering, you're controlling the steam to give you a steam water temperature. So you're controlling the steam pressure rather than the temperature, and I think the correlation in engineering terms is actually more accurate using this method. It's certainly more reliable, but nevertheless you don't need precise control over the steam pressure or the steam boiler temperature, which correlate. What you need is accurate control over the coffee water temperature. Now, you will not get that with this when it's on a single boiler heat exchanger machine. That's my point. You will get it if you're using something like a KB90, which then has a temperature probe, and it's measuring, for the steam boiler, yes, but then for the individual coffee boilers, they have PIDs as well and temperature probes, and they will be then controlling directly the temperature of the coffee extraction, which is really, really good. On the other hand, if you have a machine like this, you'll have steam boiler, heat exchange circuits. This is a stupid idea because you're controlling the temperature of a steam boiler. You're not controlling the temperature of the coffee extraction at all, because it goes through a heat exchanger system, and that drops down in temperature quite a lot. So it has a rough correlation, but it's extremely rough. There's no point doing it. You'd be better off cutting the complexity of having this, which then controls, in this case, a contactor, rather than having this totally unnecessary complication. Have a couple of simple, cheap temperature probes drilled into the coffee heads, so that when the extraction takes place, you know the exact temperature. It's not directly controlled by that. All this does is create an unreliable situation that can scale up, and nobody services correctly anyway. So, going back to where we were, point is, if you're going to buy one, you don't need a single boiler with a temperature control PID. You don't You don't generally need it. If it's a Gargia or a Sylvia, Rangelio Sylvia, different scenario. That's fine. They're quite different in the way, but if it's a heat exchanger machine and the PID is simply controlling the temperature of the steam boiler, there is no point knowing that temperature. You don't need to, unless you are really finicky for some particular reason about the steam pressure, which you don't need. You still don't need it. So rant aside, engineers, people who are designing coffee machines, just use this. 99% of cases, this is all you need. And then give the poor people who don't want to have complexity and bills, higher bills later in servicing, just give them a simple temperature readout for the coffee. So the actual, just as it's hitting the coffee puck, give them that on a readout on the screen. And if they want to drop the temperature by purging a bit of water through the head, they can do that on a heat exchanger machine. That's how they work. But don't give them this illusion that they're controlling the actual temperature of the coffee extraction via a PID when they're not, and you're just overcomplicating it and making it more expensive and less reliable. Cheers.